So, melanoma is a cancer. The damage from UV can be inflicted very quickly.
It's a devastating diagnosis. What are the best options?
While our existing sunscreens are not necessarily giving predictable blockage against UVA, the industry knows and advertises broad spectrum, but what we need is regulation, and those kinds of guidelines SPF has been working on, and the ingredients, and hopefully safe ingredients, that will protect against UVA, I think will be a very important advance in skin cancer prevention.
Hello and welcome to the podcast. This is Jason Kam, and we have a fascinating guest for you today with some really cutting-edge, groundbreaking information. I'm being joined by Dr. David Fisher, MD, PhD. Dr. Fisher is an internationally known researcher, clinician, and academic. He's chief of the Massachusetts General Hospital Department of Dermatology at Harvard Medical School in Boston, Massachusetts. Doc, welcome aboard.
Thank you. It's good to be here, Jason.
So why don't we start by, building on that intro. Give me a little bit about your background and how you got into the field that you're into today.
Sure. So I'm actually trained as a medical oncologist, and also it happens a pediatric oncologist. So my focus came from the world of cancer. Um, and my interest in melanoma and ultraviolet radiation, the interactions between sunlight and this particular very deadly form of skin cancer, came from, I would say, one of the striking features of melanoma is that it is, in principle, one of the most preventable types of cancer. If you step back and look at cancer in humans, actually, only a very tiny fraction of them are preventable. We don't really know what causes most of them, and even to the extent that we do, with maybe the exception of cigarette smoke and a few viruses, the vast majority of cancers, we don't have a cause, and even more importantly, we don't have ways of preventing those causes from inducing the cancers. But the relationship between ultraviolet radiation and melanoma is rock solid. It is heavily established. Other than maybe the tanning bed industry, nobody really refutes it anymore. It's pretty broadly accepted, and there are very good reasons mechanistically to understand why this is, why that connection is. And yet, despite that fact, the incidence of melanoma is very high. It may not be quite increasing as much as it was previously, but our ability to prevent it, even with education, with a variety of sun-safe behaviors, things of that nature, while maybe better than it had been, we're not really doing so well. We ought to be doing way better, and if we really understood what the cause is, you would think that the incidence would plummet, and it has not. So this fascinated me. It allows us to ask, how does ultraviolet radiation cause melanoma? What other influences might be at play? And what is it about ultraviolet radiation that leads people to seek it out or not necessarily prevent their skin from being exposed to it?
Right. Well, UV radiation is obviously very important. Humans evolved living under the sun our entire history as a species, all life, right? And it's essential to make vitamin D and nitric oxide and some other things. So why don't you talk about this double-edged sword here that we've got, where we need some UV presumably, but not too much, and how do you balance that?
Yeah, this is a tremendously important question. So I think there's actually evidence that evolution, human evolution, but actually that means the evolution of animals, and in fact, I think evolution of terrestrial animals, animals that live on land rather than in the oceans, and even to some extent, animals in the ocean have fought the battle of vitamin D. Vitamin D is a fascinating kind of Achilles heel, in terms of the biology of our organism, because we need vitamin D in order to absorb calcium in the intestines, and we need to absorb calcium in order to make bones. So all the organisms that the vertebrates, huge numbers of species that have bones in them, which are all the larger animals, are really dependent on the ability to absorb calcium, and then this vitamin plays an integral role in this. And this is not a vitamin that is easily obtained in our diets. We can obtain it in certain aspects of the diet that are kind of interesting, but we can actually make a good part of the vitamin D molecule from actually the same backbone as cholesterol that's related to the cholesterol biosynthesis pathway. But there is one step, one chemical step, where a certain carbon-carbon bond gets broken by a very specific wavelength of ultraviolet radiation called UVB. And UVB hits that precursor molecule, breaks this one carbon-carbon bond, and now the rest of the molecule can be made in our bodies, liver, kidneys, it goes everywhere, and it does what it needs to do. In the absence of UVB exposure and some alternative source like a vitamin D supplement that you might get from a pharmacy or something, people will become vitamin D deficient, and vitamin D deficiency can be fatal. It's a condition called rickets, and in childhood, you cannot you can become severely calcium deficient and fail to make bones, have fractures and all sorts of severe problems. And so this has been an evolutionary driver to make sure that UV is present. And I think even in the ocean, it's interesting that the bottom feeders, the vertebrates, the big fish that live at the very bottom of the ocean, they have the same problem. And they apparently get their vitamin D from algae that live at the top, but then kind of fall down to the bottom, and the bottom feeders eat them. But what's really interesting is vitamin D is it's a fat soluble vitamin, and those fish make their livers very, very fatty, and it therefore holds on to vitamin D. It sequesters it so that they can maintain vitamin D for a very long time. And I don't know if you grew up ever hearing about cod liver oil. People claimed it was a punishment because it was supposed to taste really bad, but actually, it was a drug. It was vitamin D. That's what was in there, and it's because cod live at the bottom, and they hold on to their vitamin D. So you can see, all the way across, the animal kingdom, the battle of vitamin D was very important. I think that in the case of humans, um, recent evidence has come to light suggesting that there are behavioral consequences of ultraviolet exposure on our skin. And one of these that was discovered about 10 years ago is that UV induces the synthesis and the release into our blood of beta endorphin. And endorphin, as many people are aware, is one of the body's natural endogenous opiates. And this was demonstrated even in animals where mice were given very low doses of UV, not sunburning doses, low doses. The mice actually became numb. They had like the analgesic of, or the sensory effects of opiate drugs. They're great pain drugs. The mice couldn't feel pain, they couldn't feel temperature, but if you gave them naloxone, the opiate antagonist that you would give a person who had just had an overdose of heroin, let's say, the mice now had their pain thresholds normalized. And so this led to the discovery that UV radiation was causing a skin reaction to produce endorphin. This was going to the brain, and it was even capable of inducing dependency, in a sense, an addictive type of behavior. And ultimately, it was possible to see the sort of animal psychology experiments consistent with a preference, what we might assume is a kind of euphoria, that they actually feel better, um, and um, and this could be traced to the action of ultraviolet radiation on our skin. Probably, we can say in retrospect that this may have been a way of evolutionarily preserving vitamin D levels, because you can imagine 50,000 years ago, you couldn't go to the local pharmacy and get a vitamin D supplement for pennies. Instead, you had to be outside. But if you lived in Scandinavia and you're in a cave in the middle of the winter because it's freezing cold outside, and there are probably predators waiting right outside the cave for you to come out, you would rather stay in the cave all winter long. But if you're there with your family and little children, they and you probably will die of rickets, of vitamin D deficiency, unless you get out. So wouldn't it make sense evolutionarily to feel better going outside or need to feel depressed if you stay inside? And in fact, a relationship has recently been discovered between vitamin D and opiate signaling. Vitamin D deficiency strengthens what appears to be the euphoria or the behavioral benefit of UV. So we think that this is part of a whole behavioral network that's in our genomes, and, unfortunately, from the perspective of melanoma, it's not good news.
Yeah, yeah, I know. I was just going to say, so nature has found a way to incentivize people to go out and get as much sun as they can to produce enough vitamin D to keep them healthy. But then, and I think where you were going with it was the consequences of getting too much UV radiation, and I imagine that varies by possibly skin tone or color, and we can get into that. Or whatever other genetic variables that put one individual at risk above another when it comes to getting too much UV radiation. So why don't we get into the risks? We just covered, why getting enough sun is actually important to make vitamin D and so on. Now let's get into the consequences of all this.
Sure. Um, One little final point on the UV importance of UV and vitamin D just before I leave it, because it's a terribly important public health deal, which is that I don't actually personally subscribe to the idea that a little bit of UV is a good thing for vitamin D purposes, because you can get that vitamin D from a supplement if you need it. You can easily measure your level of vitamin D, and if you need it, you can get it very inexpensively from multivitamin or pure vitamin D supplements. It's the same vitamin, and very rarely there are people who cannot absorb the vitamin, but by and large, it's easy to do that. Then you're getting vitamin D without the carcinogen of ultraviolet radiation, which will give you the same vitamin D, but with cancer risk. And people have not really identified a low dose of UV that is so low that you can predictably say there is zero cancer risk.
Right. That was a question I was going to ask. How much sun is safe, or is it sounds like you don't really know.
Correct. I think what we can say is that the risk of UV for skin cancer and for melanoma specifically is in fact highly variable, just as skin pigmentation is highly variable. It's one of the most polymorphic genetic traits that we see: hair color, skin color. It's not like there are 2 or 3 or 4 colors, there are hundreds of them and shades, many, many different shades. And correspondingly, the risk or the incidence of melanoma and other types of skin cancer, also are highly, highly variable. And to a very large extent, they correlate with skin pigmentation, but they also correlate with the ability to tan. So they're individuals with relatively light skin who tan quite well, and typically they have a greater degree of protection. But there are whole swaths of the Earth's human population, where pigmentation is darker and where the ability to tan is much easier. And those individuals typically have much lower incidence of melanoma in the sun-exposed portions of their skin. There are much rarer forms of melanoma that happen in what we would say where the sun doesn't shine, under your clothing or, in we call mucosal surfaces in the mouth, in the nose, in the genitourinary areas. Melanoma does happen. It's very rare in the palms and soles, another example. And in those anatomic locations, the incidence of melanoma is pretty much the same across the board for all the human populations. It's in the sun-exposed areas where the risk really varies as a function of pigmentation.
Are darker skinned people a little bit better protected? Like, how does it break down by, say, race or ethnic group on that front?
Absolutely, yeah, the incidence is significantly lower, but it is not 0. And so for those with dark skin pigmentation and intermediate skin pigmentation, Asians, Hispanic, Mediterranean skin tones, All of those individuals as a group tend to have a lower risk of melanoma than the Caucasians, and then even among the Caucasians, the lightest ones, which are typically red-haired, very light-skinned, tones, those are the individuals with the highest risk. I do wanna make one particular point about melanoma in the darkly pigmented population because it is not 0, and this is part of the evidence that we don't while we know that the danger and the risk from UV, to a large extent mitigated by the presence of dark pigment, it is not 100% protection, and one of the very sad outcomes that we have increasingly noticed recently is that melanoma in darkly skinned people, unfortunately, can do worse because it's not necessarily diagnosed as early. And that's because physicians may not be paying attention, patients and family members and friends may not be paying as much attention because they assume the risk is low. But in fact, a pigmented lesion or a skin lesion that is worrisome, we do have to take very seriously in people even with darker skin pigmentation because melanoma still can happen. And that can be, unfortunately, just as life-threatening, as it would be in the lighter-skinned people.
What about other forms of skin cancer, not just melanoma per se? How does sun exposure affect risk there, like basal cell and all these other issues that you can get?
Yeah, so the 2 most common non-melanoma skin cancers are basal cell carcinoma and squamous cell carcinoma. And these 2 are among the 2 most common cancers on the planet. They are associated with, again, sun-exposed areas of our skin. They happen in the lighter skinned toned individuals, and they're quite directly associated with the incident, exposure, to UV radiation. They have also typically been seen, especially squamous cell carcinoma, to be benefiting in terms of risk, that is to say preventative risk, by the use of sunscreens. So sunscreens have demonstrated very clear protection against squamous cell carcinoma. That's great. We wish we saw that with melanoma. There is a signal of protection for sunscreen use for melanoma, and we strongly, strongly encourage people to be using sunscreens. People with light skin all the way down to dark skin, sunscreen clearly protects against burning, sunburns. It's measured, the SPF value that is placed on the little bottle of sunscreen, the sun protection factor, is a measure of protection from burning. If you have an SPF of 10, it means you can have 10 times the dose of UV where you just would start to burn for a standard skin tone. That's kind of what it's calibrated against. And so what it is measuring is only the protection against burning. Um, but what about its protection against cancer? Because I think for many of us, cancer is the much more, well, for sure, it's the more dangerous risk. Um, and unfortunately, there is nothing in the SPF that has measured cancer risk. We hope it may correlate, and we think it does, but the correlation is weaker than we wish it were. And the clinical studies that have looked at people who use sunscreen versus those who do not use sunscreen, I would say the consensus clearly at this point is yes, use sunscreen. It probably provides some protection, but the magnitude of that protection is way, way smaller than we wish it were. If it were as good as it were, let's say, against a sunburn, we know how well it works for a sunburn because if you miss an area between your fingers, you're gonna get a burn in those areas between our fingers. Everybody's had this experience, and you don't make that mistake many times. Um, for skin cancer risk and for melanoma risk, however, we do make that mistake, and there are other nuances about what sunscreen does protect against and what it does not protect against, UVB, UVA, which I can go into if you're interested. But there's more and more information suggesting that we need better sunscreens, and perhaps with time we'll be able to place a much more effective strategy to get really good protection against melanoma.
What is the difference between UVA and UVB? Is one worse than the other? How does that break down?
Yeah, so the ultraviolet portion of the is what are we talking about when we say ultraviolet? So We refer to the radiation that comes from sunlight as electromagnetic radiation, and it actually includes a continuum of wavelengths. So these are categorized by how long the waves are, sort of, waves in the ocean down to waves, back in the days when telephones used to have a cord, you could kinda shake it and you could see the waves going up and down, and or if you have a violin or a cello or these or a guitar, you can see the waveforms. Those are sound waves that we're hearing. So when you get into the light waves, there is the visible portion, and those are the light colors that we can see. And then when you get down just smaller than the visual portion of the electromagnetic spectrum, you get to ultraviolet. That's the next region. And then if you get even smaller, you get to X-rays, and nuclear medicine kind of areas, or bombs and things of that nature. Those are very, very small wavelengths. In the ultraviolet radiation area, UVA is longer, UVB is a little bit shorter. The difference between these is actually striking in terms of the biological consequences. UVB, dose for dose, is more damaging in the sense that it interacts with the DNA in our cells, in our skin, and it mutates it. It also causes that carbon-carbon bond to break in vitamin D. So UVB is what you need in order to make vitamin D. And it also triggers the inflammation that we call sunburning. So UVB is really the culprit for sunburn, for I shouldn't say the culprit, but the good guy when it comes to making vitamin D. And it is definitely a bad guy in terms of causing mutations that will contribute to melanoma risk. The problem is that UVA, while it is not quite as potent molecule for molecule or wave for wave at mutating DNA, it also does mutate DNA, and it also does contribute to skin cancer formation, including melanoma. The problem is, if you have a sunscreen that only blocks UVB so that you don't burn, but it does not block UVA, you actually may feel paradoxically safe when you're at the beach because you're not burning. In fact, the sunburn might have been nature's alarm to go off and say, "Get out of here. You're roasting. This isn't good
Yeah.
for you." But you've
Mhm.
blocked that alarm. It's like you've turned that off. And so you sit under the sun, you don't burn, your skin doesn't get red and hot, but the damage from UVA is nonetheless penetrating in the skin. UVA of the UV spectrum, UVA is 95% of the ultraviolet radiation coming in. So it is very abundant. Fortunately, not as potent as UVB, but it is potent and it is damaging. It is most of the UV that is in tanning beds, for example. They have also clearly been implicated in skin cancer risk.
Yeah.
So that's where part of this challenge comes with sunscreen, and I and others have been in touch with the FDA. There's been quite an outcry that we need sunscreens that are called broad spectrum that will block UVA as well as B. Um, the industry knows and advertises broad spectrum, but what we need is regulation that will quantify and verify that UVA is truly being, rather than just a self-proclaimed, "Yes, we can block some of it." We want a number. I want an SPF 30 or an 80 or something that says this really works. And that those kinds of guidelines SPF has been working on, and the ingredients and hopefully safe ingredients that will protect against UVA, I think will be a very important advance in skin cancer prevention.
I was gonna ask, are there better ingredients than others that people might look out for currently on the market, or any I don't know if you wanna name brands or anything like that, but what are the best options for people who, you know, are gonna find themselves in the sun?
Yeah. So, unfortunately, not in this country because the safety testing for the UVA ingredients, the ones that do filter out UVA very effectively, have not undergone safety testing. And FDA apparently wants that, and we can't argue that because we're giving this to healthy people, and we want to be very careful about it. In Europe, however, European sunscreens do in fact utilize ingredients that effectively block against UVA. So in other countries, one can obtain these. Um, They're not being sold yet. The good news is that FDA is aware of this, and I think more importantly, the industry, well, as importantly, the industry knows, and hopefully the industry will be working very hard, and I'm sure they are actively at this time, to try to incorporate effective UVA blocking ingredients so that there will be real broad spectrum protection. What can we do right now? Hats, long sleeves, shade, avoid the very sunniest times of the day, walk on the side of the street that's in the shade. These are all ways that are actually much more effective than you might think. And just recognize that the damage from UV can be inflicted very quickly in a short period of time. And again, I would emphasize, even while our existing sunscreens are not necessarily giving predictable blockage against UVA, the UVB protection is important too, and so we do strongly recommend using sunscreens, and hopefully sunscreens will get even better with time.
Yeah, you would think within that industry, there'd be a massive incentive for one brand to try to get a lead here because the market is so what an opportunity for the first company that jumps in with this.
Exactly, exactly.
So why don't we turn our attention a little bit to melanoma? And I guess I would ask, I've had friends that have had it and passed away from it. It's a devastating diagnosis, but for people that don't know much about it, what exactly is melanoma?
So melanoma is a cancer of a cell type in our skin, which is called melanocytes. Melanocytes are the cells that make pigment, melanin pigment. They synthesize the melanin and export it typically. The melanin doesn't typically stay in the cell. They export it typically to 2 different targets. One is hair, so they exist in the hair follicle, they make it, they release it, and then other cells incorporate it onto the matrix of the growing fiber of keratin within the hair. And the other place they send it out to is the keratinocytes, the other cells in the epidermis, the outermost layer of our skin, so that if your skin is darkly pigmented, actually the pigment is not sitting in melanocytes. It was made in the melanocytes and then exported to the other cells surrounding the melanocytes, and that's why you have an even tone of pigment there. Um, but the melanocytes, unlike other cells in our skin that tend to turn over, they're often damaged by ultraviolet radiation. They mature and then they slough off. They grow up to the top of the surface and then they slough off, and new cells give rise, stem cells actually give rise to new cells. They're constantly regenerated. But the melanocytes in our epidermis, in our skin, they're here to stay. And so the cells you have from birth, by and large, are the same cells that you have decades later. And that means that if they have been exposed to sunlight and UV and have incorporated mutations, the number of those mutations has been gradually rising and rising and rising. They haven't been replenished with a brand new set of melanocytes when you're 20 years old or 30 years old. And that accumulation of damage is probably why the melanoma, the cancer, is so filled with mutations. And correspondingly, because these cells need to survive, if you're a child and you go out and you get a really bad sunburn and you've been heavily mutated in your melanocytes, it seems that we have evolved for our melanocytes not to die from that amount of damage. Our keratinocytes, other cells in our skin, if you have a bad burn, those cells will actually die. You may get a blister, they'll slough right off, and then new skin grows back. Not melanocytes. They have evolved to be survivors in case you decide to go to the beach the next day or the next day. And that property of resilience or survival after the damage of UV exposure, unfortunately, is perpetuated in the cancer of melanocytes. So historically, melanoma was a cancer that did not respond to chemotherapy. It did not respond to radiation therapy. It didn't respond to all the treatments that were showing efficacy in other forms of cancer, in childhood leukemia or in, Hodgkin's disease, cancers that had a very respectable cure rate. Same drugs, the melanoma would grow right through it. And we
Yeah,
think this was related to the melanocyte and its relationship to the
it makes
environment.
perfect sense. Yeah. So what are treatment options if someone should, God forbid, be diagnosed?
So melanoma has undergone one of the most exciting revolutions probably in modern oncology, maybe in the last century, I don't know. So, melanoma, advanced metastatic melanoma, which is the scariest form of melanoma because it has a propensity to spread, a disease which maybe 10 to 15 years ago was incurable, probably people wouldn't live more than a few years at most, has now become curable on the order of 40, 50% of the time.
Wow, that's great.
And this is due to the success, primarily the success of immune therapies that have completely transformed melanoma from being such a resistant cancer to therapies to one of the most responsive. If you have the right melanoma, and we can talk about what makes a melanoma more responsive or less responsive, and the right treatment, the right way of activating the immune system to harness the activity of the immune system to kill the cancer.
So before we get into the what you just brought up about the different kinds and how they respond, let's just take a step back and I'll ask, how often should patients go to see their dermatologist, um, to get checked out, and how effective is that preventative? Is once a year enough? Do you like to see patients more often than that? What's the best advice you could give to people who are listening in here?
So the best advice is to be evaluated and allow a dermatologist to determine how often they need to be seen.
Mhm.
Some people need to be seen very frequently because most importantly, they may have a history of melanoma or a family history, or they may have had very heavy UV exposure in childhood or for some reason. Um, Other people may have a much lower risk and an annual exam is sufficient, um, or even just a good exam by their internist or a primary care doctor. So it's highly variable, just again, as skin pigmentation is highly variable and the risk of melanoma is highly variable across our population. However, melanoma, the very best therapy for melanoma is early detect well, the very best is prevention, of course, so that goes without saying. But early detection and removal, by catching a melanoma in its earliest stages is said to cure, probably 95, 98% of the time, simply removing it, end of story, nothing more to do. Overall, if you ask when patients are diagnosed with melanoma, some of whom are gonna have thicker melanomas or even advanced melanomas at the time of diagnosis. Overall, about the number we use is about 6 out of 7 newly diagnosed melanomas are curable just by removing it. So most melanomas are diagnosed on the skin relatively early. If you have a concern, get it checked out. Waiting, delaying is not a good idea because you want to catch this early. If you catch it early enough, remove it early enough, it's over and you caught it. And there's statistically very good evidence support for that approach.
So I don't know what percentage of people out there actually do go for regular checkups with their dermatologist, but I would imagine there are a lot of people that don't for whatever reason. And for people that aren't getting checked out, are there things that they could look out for themselves? Any symptoms or weird things on their skin? What might tell someone, oh boy, I've got a problem. I really need to actually go see a doctor about this?
Yeah, I mean, there's a huge amount of information about this. There's what's called the ABCDEs and their acronyms of what the a number of features, the size, the pigmentation, the symmetry, lack thereof. There are numerous ones. I don't think I have quite enough time to go through a full primer on how one should do this. But the bottom line is, if you're concerned, have it checked. Um, One of the challenges is dermatologist access can be difficult. I know in our own department, we wish we had twice the number of doctors and appointments available. Have it checked by somebody else if necessary, because if a primary care doctor sees it and is trained sufficiently to say, I don't know, but I'm not sure, they can usually intervene and make sure a dermatologist will see that patient quickly. And we have a special process if there is a question of melanoma or a pigmented spot that is changing in some fashion. So there's prioritization, and I think that approach is really important. But the bottom line at the end of the day is a very low threshold for concern. Have it checked out. Don't sit on it and say, I'll wait till next year. Have it checked out. The worst thing is it's nothing. You wasted a little bit of time, but that should be reassuring.
And I think you had hinted at it a bit before, but are there genetic predispositions that would expose someone to a higher or lesser risk of getting either basal cell squam or melanoma itself?
Yeah, so the risk for basal cell carcinoma, squamous cell carcinoma, and melanoma largely tracks together, but not perfectly so. And that risk is environmental. It's ultraviolet radiation. And it's related to the skin pigmentation as well. So the lighter skin tones are associated with the greater risk of ultraviolet radiation causing any of those. So it is very common for patients who have melanoma to potentially already have had basal cell carcinomas or squamous cell carcinomas. The good thing about the basal cell or squamous cell carcinomas is those tend to be very slow growing and they have a lower risk of metastasizing than melanoma does. And therefore, they can be treated with a greater margin of safety in terms of the risk of having the tumor relapse or the risk of missing a portion at the time of surgical resection. So there are some differences. What I would say in terms of familial risk, genetic risk, that's an important question people ask all the time because melanoma often runs in families. In fact, it's thought about 5% of melanoma may be associated with a real gene, an inherited genetic risk. But remember, you can have a family that shares the risk because they all went to the beach or they all did not put on sunscreen or they all had behaviors that were being shared. Is that genetic? Sort of is, but it's not necessarily a gene that was inherited. It was a shared behavior. So at the end of the day, I think education is terribly important, and perhaps the awareness to fight the attraction of ultraviolet radiation, the feel good, and try to be wise, and especially with family members and with children, to instill behavioral patterns that will be protective and safe going forward.
Before I let you go here, any exciting new projects that you're working on or new research you're excited about coming out of the field?
I think one of the really important ones I alluded briefly to is the efficacy of therapy now for advanced melanoma. There's been enormous excitement about a set of drugs that stimulate the immune system to kill the cancer, to kill the melanoma. Um, Melanoma has sort of been the poster child of this field, and the ability to activate the immune system to attack our own cancer is probably over a 100-year-old concept, that did not work predictably. Rarely there would be these very, very anecdotal instances where somebody's cancer would go away after some inflammatory exposure, but nobody could understand what was going on. We now have drugs that will explicitly activate lymphocytes of the immune system and predictably produce complete regressions that are what appear to be durable. We would hope we can use the word cure, but that's what it seems to be in close to 50% of patients with metastatic melanoma. Why does that occur? There's actually a remarkable reason. This is a slight oversimplification, but I think it's conceptually easy to grasp, which is that our immune system is looking for things that are foreign. Our immune system was not evolved to attack our own cells. Cancer is our own cells. So our immune system actually has mechanisms in place to prevent it from attacking our own cells. That would be autoimmune disease. We don't want that. And there are these things which are called checkpoints that prevent our immune system from attacking our own cells. But our own cells look just like whether they're cancer or not, our own cells are our own cells. How would the immune system discriminate? And when I mentioned that the ultraviolet radiation is inflicting mutations throughout the genome and melanoma has acquired thousands of these, Those mutations are causing tiny changes in the corresponding proteins made from those genes. Most of those changes actually don't cause cancer. They don't cause the cell even to behave differently. Some severe ones might even kill the cell right away, which at least won't be a cancer. The cell just won't be working. But most of them are, we call them silent. They don't actually really do much. But at the level of the protein, that little mutation to the immune system, it doesn't know, it never saw that protein before. It doesn't look like self. And when you accumulate thousands of these, all of a sudden the immune system says, like, what's going on here? This looks foreign. It might think it's a fungus or a bacterium or a virus or something. So it tries to attack. Now, if it were that simple, melanoma would not exist. Melanoma would be cleared by the immune system before it starts. But no, the melanoma fights back. It activates that checkpoint and it says, no, 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 I'm self. I'm the same person whose immune system you are. You can't attack me. That checkpoint becomes activated. And the new generation of drugs are called checkpoint inhibitors. They block the checkpoints, allowing the immune system to attack. And that is the mechanism that this new generation of drugs encounters. That's the mechanism that it utilizes. And in melanoma, it has been a complete game changer. There's a very significant signal in lung cancer. It's being tested in virtually every human cancer. Most other cancers don't have that many mutations, so it's harder for the immune system to recognize it as foreign. And if it doesn't recognize it as foreign, it won't work. Or other strategies need to be deployed to get the immune system to be tricked into hitting the tumor. So there's a lot of work going on to try to get this applied to many other cancers, as well as the other 50% of melanomas where we need to be doing better. But this is probably the most exciting moment in the development of therapies for advanced cancer and certainly for melanoma, in recent history. So it's a very exciting time in that field.
Are these drugs just, you know, are they on the market yet, or are
Oh,
they
yeah.
just this is just academic research?
No, this is now FDA approved in melanoma. In many cancers, melanoma has the biggest benefit to patients because a high fraction, close to 50% of patients will really have these very durable, long, major responses. In other cancers, it's a smaller fraction of patients. But, with a baseline of very, very, very low efficacy, that's enough for the FDA to have approved it. So these are absolutely out there. They're on the market, and new drugs, new research is very actively being pursued, and combinations are being tested actively. So enormous excitement in this field, and it is unfolding as we speak. So exciting.
Okay, well, let's end that on a high note. That's very, very positive news for what I thought was going to be a somewhat depressing discussion about melanoma, but it sounds like there really is hope on the horizon. So, Dr. Fisher, thank you so much for joining me today. I really appreciate it. This was fantastic, really.
Great, great. Okay, thank you.